Good afternoon. Welcome to our Terrascope webinar about the use of CropSAR, a fusion algorithm to overcome cloud cover limitations for more accurate crop monitoring. Today, we have the pleasure to welcome Stefan Lievens. Stefan obtained a PhD in physics from Antwerp University, and he's been working at Vito Remote Sensing since 2007 with a special interest in hyperspectral imaging from satellites and drones, mainly for vegetation monitoring. Today, he will talk about CropSAR, which overcomes a major problem in optical remote sensing, and that is clouds. Stefan, the floor is yours.
Thank you, Jurgen, for the introduction, and thank you all for joining today. It's easy to get excited about a topic like CropSAR, and that's not just on the technological side, because it's of course an interesting technology, as we will explain, but it's also one that has some real relevance, some real even societal relevance. And let me explain that first to you. So, and I'm talking about food security now. Now, yeah, everybody knows world hunger is a big issue, and that's of course why it's one of the sustainable development goals of the UN. And one would think that hunger in the world is something that slowly is decreasing and things are going a good way, but unfortunately that's not always the case. And when we take some recent numbers with us, we see that indeed hunger was declining roughly until 2017, but after that, both in absolute numbers and in percentage of people actually affected by hunger, it is rising again, or maybe stabilizing, but still it's way too high. So it's really important that this is tackled. And in Dutch we have a really nice word for that, saying the urgency of that, and it's the word broodnodig, meaning yeah, it's as much needed as bread. And I think that word really says the relevance of looking at food security. Now that's vitally important to food security, but yeah, what can you do if you need to produce more food, so everybody know this, so you can eradicate hunger. Now, how to do that? Well, there could be different ways. You could have a bigger area where you do agriculture. That's a possibility, or you could make it more, you could intensify the production. Now, increasing the yield, since we don't have an unlimited space on Earth, and we are quite a lot of people on Earth, increasing the yield seems like the preferred way, and there's still a lot of gains to be that can be made there. So increasing yields, yeah, well, there's many ways, and we will look at one of those, and that's monitoring, because monitoring really can help closing the yield gap. By if we can more closely monitor what happens on the field, we can make sure that the crops are doing well, and we get the best yield that is possible. So this is a big task, and at Vito we have been working on this for many years, and we also developed quite an interesting solution that helps monitoring crops. And you might have heard of it, because it's called Watch It Grow. Initially it was made only for potato, but it is as much broader. It can be used for many other things as well. It's a platform that allows digital crop monitoring, and it does so using different types of data. Actually, all the data that the farmer needs to know to really know what he needs, what is optimal to do on the fields. Now that data is his own field data. It can be weather, it can be soil, but an important aspect is also the satellite data, because the satellite data can give regular updates on what is coming, what is happening on the fields. So that is a big advantage if you want to perform that kind of monitoring. Now, in that satellite images, so if you have these satellite images, this is another picture of what Watch It Grow can do in reality. It really on parcel basis, you can really have control and see everything that's going on in detail, and quite a lot of that information can come from the relevant satellite images, giving really indicators on what is happening with the crops. Okay, so in the rest of this webinar, we will exclusively talk about the satellite imagery and what they can do for crop monitoring. So let us see what satellite images we are using. Well, luckily we have at there is you all probably know the Copernicus program, which is like the satellite program giving us satellite images, Earth observation data from the European Union, and it's in fact the biggest program in the world offering this data, offering free and accessible data. And the Copernicus program, it has quite a number of different satellites, all geared at solving different problems, giving different types of information. There's an overview of the main missions here. But when we think of crop monitoring or agriculture in general, not all of them are equally important. And the ones that are the most important are these two. That's the Sentinel-1 and the Sentinel-2. Let us go briefly over them to see what they can do for crop monitoring. Now, Sentinel-2 is a very interesting mission. It's a mission that is sort of combining things that are very intuitive, because it is an optical instrument. It sees the world like we see it, and then some more. It has a multispectral instrument, so it has visual bands, simple red, green, and blue, like we are used to. So it can give us images that we immediately can relate to what we see with our own eyes when we go out on the field. But it also has quite a lot of additional bands, which I call here diagnostic vegetation bands. So it can give a lot more detail than what we can see just from an RGB image. Apart from that, it's really a mission that can do worldwide land coverage. And it does so on a fairly short repeat time, every 5 days, more or less, a bit depending on latitude. It has a new observation, so that is interesting, and it is really what we need for monitoring crops, monitoring vegetation. And it also does that at a quite high spatial resolution, depending on the band, but it can be 10, 20, or 60 meters GSD, so pixels that can be as small as 10 by 10 meters, which sort of aligns well with the size of parcels. So with that kind of imagery, you can really see the parcels in quite some detail. Now that was the Sentinel-2. With the Sentinel-1, it's a bit more exotic, let's say, because it's a radar mission. And a radar mission, it doesn't just capture information. It works with microwave, of course. It doesn't just capture them. It also sends them down, and then you really know what happened by seeing what the interaction is. And actually, the Sentinel-1 is a C-band, which almost penetrates into vegetation, and almost means that there is a lot of variation and interesting things to see. It also has this worldwide coverage, somewhat longer repeat time, and also a high spatial resolution. So it gives very different information, because the interaction of radar with vegetation and how it comes back to the satellite, it is a lot less intuitive, but that is also an advantage, because it then gives complementary information. And putting all that together, I made a small overview here. So with the Sentinel-2, you can get a visual image, and everybody immediately see, oh yeah, I see the fields, I see the farms, I see the road, I see. That's quite good. Although there is a lot more in that Sentinel-2 image as well, which I didn't show on this slide. With the Sentinel-1, you get also multiple bits of information. You get an amplitude image, which sort of can relate very, very finely to soil moisture, like the roughness of the surface, and also the crop status and the types of crop, or even the way the lines are on the field. That's also possible. But apart from that amplitude image, you also get a second image, is the coherence image, which always is used on. Images are used of 2 different dates, and they are compared, and everything that is very stable will show, and the parts that are not stable, that have changed, which can be because of the crops, or it can be because of a harvesting, or it can even be because of the rain, different reasons for that, but they will show up differently. So you can imagine that with these 3, you can really have a very detailed monitoring of what's going on your field. The question is still how to do that. Now, what we often want to do is measure what we generally called greenness. Now, greenness, that's a bit of a fluffy concept, that depends on how much vegetation is there, how well it is doing. So there are different indicators, some very simple one using a couple of bands and indices, or some very complex models that give a bit better the biophysical parameters that relate to the field. Some of them you might know, like the NDVI or the F cover, the UPAR. Now, in general, because it goes for all of them, the greenness changes over time. That's the main thing. It might be very low in winter, and then the crops start growing, becomes very high, and then suddenly the crop is harvested and it goes down again, and so on. This is a generic curve. But from this, yeah, we can of course see when the growing season starts, when it peaks, and when it ends. But in reality, you would not always get that perfect curve, because it might be lower, and then that is interesting for the farmer, because he sees that his crops aren't doing optimally well. So this could be drought stress, or it could be something else. This is just an example, but the principle is that from these curves, the evolution over time, there's a lot more that you can learn from that than you could from just a single image, because a single image, if you make an indicator out of that, it gives you one point, one value of greenness, and yeah, then I would not know what to do. It's just a value. But if you see this evolution over time, even if you have only half the curve, you know what is going on and whether there's something to be, an action to be taken by the farmer. Okay. Let us move a little bit further. So I just mentioned that time is such an important aspect, but you remember that I said the Sentinel images, they come with regular updates. So that is an advantage. So this is just a time-lapse movie that I made with the Belgian platform Terrascope, where you can easily just select a region and a timing to start and to end, and then it will give you a time lapse. Oh, sorry. I have to go back again. And then it easily gives you a time lapse movie, and it again gives you the indication that yes, it's the time aspect that's the most important here. If you really want to monitoring something, it's the evolution over the year that is key. Now, this is a bit of a perfect picture. It gives a bit of an optimal view, like, oh yeah, this is wonderful. We can all see that, but in reality, things are different, because in reality, there's clouds, and clouds are a big showstopper, because in reality, in more than half of all the images, we won't be able to get these nice pictures, because there will be clouds, fully clouded, partially clouded. It depends. And just for the sake of it, I just again with Terrascope, I had a look at these are the Sentinel-2 acquisitions from the last 3 months, from April to now. And I just said, show me which ones have less than 10% cloud coverage. And that are the 5 green dots, and all the others, so it's more than half, but it has been not a great spring, are just too clouded, and you won't be able to see all your vegetation with that. So it's a big disadvantage, and I'm not sure. To me, this sounds like really a showstopper. What can we do about it? But we also like to know how you think about that. So maybe it's time to ask the audience and launch a poll. So the question is, cloud cover, is it a big issue for your use case? You all do different things. Is it very important for you? Not at all, or maybe only sometimes? Or do you often have problems with clouds, or maybe all the time? So let's see. I hope you can all see the poll. I see the answers coming in, and we have quite many answers already. I'll give you a couple of seconds more to answer. But I think the trend is already very clear. It goes faster than with the political election here. I see the trend is very different. That most of the people, like 63%, say they often have problems. They often have an issue with clouds, and those that don't often have an issue with clouds, well, most of them always have an issue. There's only 5% that are a bit optimistic and said, yeah, maybe sometimes. And there's nobody that likes clouds here. Okay, no cloud scientists here, but yeah, we were talking agriculture. So yes, it's not a big surprise. Cloud cover affects us all, and if you want to use optical images, you have a big issue. So that's why we're here, of course. That's why we're here, and that's why we talk about CropSAR, which should be a solution for that cloud problem. So let's move to the solution. So what is very instrumental to this solution is that with the SAR signal, with the synthetic aperture radar, the radar signal of Sentinel-1, it is possible to predict some of the vegetation indicators, the indicators that you normally get from the optical images. We said this greenness, as if you remember it, the greenness. If you can sort of predict that by looking at a different signal, and that different signal, very importantly, the Sentinel-1, is one that is not affected by cloud. So how does that work in practice? A bit like this. This is an optical signal here. The top graph, an optical signal of something that goes over time. This might be an NDVI, or it could have been another indicator moving over time, and that is a very good signal. But you also see that in some areas the weather was good, so we have lots of dots over time, and in other areas, yeah, there were the days where everything was cloudy, so you couldn't get the signal. Now the signal from the SAR, the radar image, actually it gets a bit more technical. We have two different ones depending on polarizations, but just looking at this graph, you see you have two signals that are in a way correlated with the one we really want to know about, and the optical one, but they are definitely not the same. So it's a relation. They're related, they correlate, but they're not the same. So it's not evident that you can just use the SAR signal instead of the optical one. But yeah, we knew there was something in that, so we tried our best, evolved some machine learning, and in the end we came with a prediction. So if you have the so we ended up with a model that, starting from the radar images, starting from the signal in the radar, you can predict what the optical signal is, even for and that goes for the days that you can verify it when you have an answer, and it also goes for the days when you don't have an answer. So, and important to know, this is not just some wild machine learning, some magical prediction. Well, it is in a way magical because it can unravel this complex relation, but at the same time it is very, very solid, and it has been validated. We spend a lot of time validating it, both ourselves but also many external parties we work with, like big names in the food industry, but also insurance, and with academia. We spend lots of time to be sure that if we predict something with the CropSAR way, because this is the machinery of CropSAR that is on the slide, then you can really depend on it. It might have some variation, of course, but yeah, you have that in the original as well. But it's really, really well validated. Now that's what with this system we have what we call CropSAR 1D, the one-dimensional CropSAR, because what it gives you is vegetation indicators, and it gives them per parcel, and you can make a complete time series using the SAR information. So this is a practical example. As on the top you see what you want to know. In this case we picked FAPAR as the indicator, and you see that there are only very few points where you can actually measure it in the optical image, the green dots, and all the rest, yeah, you would not know anything about it. But by using the information in the bottom graph, which is these two types, well, actually even four types of different radar information, which is correlated with the one above, the CropSAR makes a prediction for you, and it allows you to have all these detailed intermediate steps in time over time of what happens with your indicator. So and it can do this on the spot, so it doesn't need the whole curve to interpolate. It can also work. If it's here, it can already predict some without knowing the future, because otherwise it would not be very practical, not very useful. So that is what CropSAR 1 can do. Now, if you see that, well, on one hand it's wonderful, and on the other hand, people always ask the same question. They all ask this. They all says, yes, that's great, but you do that per parcel. Can you also do that per pixel? And the answer is yes, in principle you could. So we tried and we started working on that, but it's not easy. It's not easy because the pixel signals are a lot noisier, so that is not helping. There are some spatial artifacts, and also it takes a lot of computational power. But anyway, we saw that it would not be impossible, so we worked a lot harder and longer on it, because the original CropSAR, we already came up with it in 2019, if I'm right. And this one is took us a few years to develop, but it works. And the way it works, just looking a little bit under the hood, says it sort of separates the spatial and the temporal parts. I'm not going into details here, but we have a spatial encoding of our images, and once we get that encoding, there's another neural network, the transformer, that does the actual temporal gap filling. So there's a lot of high-tech AI underneath, but in the end, by doing this trick of splitting it into separate tasks, we managed to arrive at a solution. And of course, you want to see the solution, not just the machinery. Now, this is an original Sentinel-2 image where we took an NDVI, where we made an NDVI out of the optical image, and you see that in a lot of the days it's very clouded or partially clouded, so we're missing a lot of information. Now the graph underneath just gives the curve for two selected points on the image. I don't know the exact points, but it are 2 points belonging with a different crop. But just by looking at these curves, it is in fact hard to see what is going on over time. You get some data, and then there's weeks or even a month where you don't see anything. So it is really hard. So the solution to the CropSAR is really very welcome, because it fills up all the gaps, and all the gaps we had with the clouds. It fills them up, and at the same time, it can also give us all the points on the curve when we're looking at a specific point or at a specific target, and then it becomes evidence that these are two different crops with a very different behavior over time, over the year. So this is a significant thing. And when we finished that, we actually realized that by setting up all this effort, that we had actually done something like this. We did AI training. This was the under the hood model, the AI model. We fed it with lots of images of agriculture, of crops, but not exclusively. There were also other image parts. So it makes the model more generic, and it can also be, it's not limited to predicting indicators of vegetation. It can actually do more than that. And almost as a bonus, well, I'm simplifying a bit now, but almost as a bonus, you can do more than doing these indicators. You can also generate other things. You can generate even RGB or near infrared image time series. And that's what you probably have seen the image, the result of that in the announcement. Here we got some images, some just RGB visual images from Sentinel-2. But on the left side, the original, there's lots of parts that are missing because it's clouded. And on the right side, it's what CropSAR can make of it by using the additional SAR information. So it looks quite well. We are really pleased to get that result. It might not be perfect in all cases, but it definitely gives you a lot more information by relying on the SAR imagery. Now I see we are progressing pretty fast, so I will now give you a little bit more information on some specific applications that we can use CropSAR for. So a basic question is, what is happening on a field? Well, what is happening on a field? Well, the farmer knows best, of course. He knows that a lot of the things that are happening are related to time. This is an example of a crop over time. Again, there's VAPAR measured, and there's here a crop that grows twice a year. So it is growing, and then it is harvested, and then it is growing again, and so on and so on. So the key variables that we want to know about is the metrics of the seasonality, what's happening over time. And of course, the other information that is relevant is what is happening on the field. Is there harvesting? Is there sowing? Is there, yeah. These things are also important to know, but these things, they are really at a short time scale. Especially harvesting, yeah, it's one day that it all happens. You want to get information from that, you really need to have a short time scale. So short time spans are needed. It's not interesting to know harvesting had been done between September and December. Yeah, of course, it doesn't give us new info. So these frequent updates, that makes it interesting to use CropSAR, use these time series where all the gaps have been filled. Okay. Maybe this goes a little far, but actually with the CropSAR system, you can go even further and look at the emergence. When do the crops really emerge? That you can see by using some kind of threshold. But even a little more difficult is to find the harvesting, because that's a really abrupt change, and so therefore there's an additional model. I will not go into detail on that predicts probabilities of when could it be that there's a harvesting going on. And then if you put these of the two types of SAR information together, you see that there is a particular point in time where the probability is very, very high that there is harvesting. So by doing this model, you can get really, really accurate results. And the same, you can do that for different parameters. The harvesting date, but we have the number of days that there's bare soil, or the category of cover crop of the emergence. All these can be given, and together it gives like a really comprehensive package of information on the crops. Now, funny enough, this CropSAR gets all this information from Copernicus, but it also gives back information, because now the Copernicus Land Monitoring Service, it actually uses results of CropSAR in their operational production of high resolution layers. It uses information made by CropSAR on harvest, on cover crops, on fallow land, and so it improves the data which is available within the land monitoring service. So you might already be using CropSAR results without even knowing it, if you use that kind of data. Now there are, like I said, there are also applications outside of crop monitoring, even outside of vegetation. Maybe still an interesting application, I might have mentioned it earlier, is in the insurance. Index insurance, for those who don't know the word index insurance, well, farmers can get an insurance for when something goes wrong with their fields, with their crops, but usually they don't get it on the real yield, but they're using a proxy for that, and it's an index, can be a kind of vegetation indicator. So they are insured when the index falls out of the normal range, that there's probably something bad going on with their crops, and then they get these based on this index, on the value of that index. There is they can get some compensation for the fact that there are really a bad the crops have not been doing well this year. So it's not with the real value, it's the proxy that the index. But of course, it's important that this index has a good relation. It's not just a random. The farmer doesn't want to be involved in a lottery. No, he wants to be sure that either he has good crops or his insurance will compensate him. So that system is something that is really goes well together with CropSAR, and that's why we worked this out in a practical case, and we worked this out in a practical case with Schweizer Hagel. And Schweizer Hagel is an insurance company, and they do this, and they wanted to use CropSAR as a really accurate index, so that their insurance is based on something that really correlates well with what happens really on the field. So that was the key question that together we investigated that, whether you can really verify the real damages to the grassland in this case. Could you do that with CropSAR? They had tried this before with different grassland indices, but these indices always require to have a real optical image, and these are the different indices as depicted here on the graph. And then we came up with the CropSAR alternative that also produces a curve when there is no optical data available. And we see that it really correlates well, and in some cases even correlated better with what was seen on the field. So it was almost too good to be true that the CropSAR gave this accurate information. They were really happy with that. So we evaluated the performance. We were happy with the result, and now this system has been incorporated in their insurance scheme, so foreigners know about it, and it's the real insurance that is really based on CropSAR. So it's a good example also that we can really trust upon this technology, because it otherwise insurance companies would not rely on it. Maybe I can give one more example of where you can use CropSAR outside of the typical vegetation monitoring, and that is in change detection. In classical change detection, well, in Flanders we are lucky that we have very good yearly aerial images on a 15 centimeter resolution, so we can really see anything that changes from year to year, and that's very nice. But in some cases it's interesting to be a bit have a shorter time span, and you're not going to fly with an airplane every month or every week, of course. So let's see whether the satellite images can also do that. So this is a track that is still in evolution. We are looking whether this continuous change detection can also be derived from images made with CropSAR, because if you make these images just from the optical Sentinel-2 image, a month where there's always clouds, then no change would be detected. So that's very odd. So definitely we believe that CropSAR in this kind of application can also give an advantage, but we're still getting the tiny bits together to say how well it performs on that manner. So with that, I've been doing a lot of talking already. And mainly, I hope I already convinced you that there's a lot of good technology in CropSAR that can bring some real world benefit. And I guess you all now are asking yourself the question, if I want to use CropSAR, how can I do that? I already gave away a little bit with the Copernicus land service, but that's not the main way for using CropSAR. The main way is the one that we provide ourselves, and that is this one. So how to access the CropSAR service? Well, you can do it like this. We have Terrascope. Well, you know Terrascope because you're in a Terrascope webinar. You probably have heard previous ones. And the Terrascope system also includes the EO Plaza, which gives additional services you can access in a platform. And CropSAR services are included into the EO Plaza. And I think I have a short movie that explains this much better than I can do. So apart from the fact that if you have a use case, there's also going to be support. So this is the way Terrascope works. You sign into your account, you go to the catalog, and then you look and you find that one of the things you can look for is CropSAR. And of course, you go immediately to the 2D, the most advanced field, where they explain pretty well some of the things that I've also been showing earlier during the webinar. So you have an idea of what's going on. And then there's code for those who want to immediately start accessing it via a Python interface using OpenEO. And with OpenEO, you can have a web editor and start looking at the actual parcel you're interested in. You can look at, you can say what the time is that you want to study. And then the big moment is, of course, what comes out. So this is being put here, maybe some adjustments. And there's a couple of more things you can see, but even without doing too much work, with some easy steps, you can generate CropSAR results. And now it is processing. And let's just see what comes out. Well, maybe it takes a little longer than what we want to wait for, but I think in the movie it is sort of sped up, so we can have a look at the results, and we have an image where you have an OpenEO image of your exact parcel that you wanted, of the date you wanted, and that's generated with the CropSAR, in this case the CropSAR 2D method. Okay, so there's plenty more explanation if you go on the EO Plaza, because I went through it a little fast now, but like you see, it is pretty easy to access and to start working with the CropSAR system. Okay. Okay, that is still running, I think. No, that is still running. So let me so we now show you as well that it is easy to access. So let me briefly recap some of the things we have been saying today. That is, what is CropSAR? In one sentence, is completing the optical data that is missing through clouds by using synthetic aperture radar images. And that is the system that CropSAR uses. That's why the SAR is in the word CropSAR. And there's a CropSAR one-dimensional that works per parcel. This has been designed for crop monitoring. It creates vegetation indicators. And the good news is we have been using this for 5 years now. It is worldwide available for agricultural applications. It works very well. It's been verified. We can completely trust on that. And then there's, of course, the 2D version, which works per pixel, resolve some of the limitations of the 1D. It can give some broader applications, even outside of agriculture, like I showed some. And this is still a bit under validation. We are doing beta tests, so this is not a worldwide available operational service. This is under validation, but it's all looking good, so it's heading the same way. So to conclude, I can say that I can only encourage you to step into the world of CropSAR. And of course, from our side, we'll be more than happy to address your use case. If you come up with a use case, we're very interested to learn about new use cases, see whether they can be solved with CropSAR, and we will give you as much support as we can then. Okay, so having said all that, maybe it's time to ask you another question. And what we really want to know is, of course, would you like to see CropSAR available for other applications? You've seen crop monitoring, but yeah, there are other applications as well. It's very interesting for us if you would have a preference to see what kind of applications you could benefit from or are interested in. And now I see the results coming in, and it's really getting more interesting, because there's not just one winner like in the previous poll. So I let the results come in a little longer. And we are almost there. Maybe some people find it really hard to decide. So the good thing is, or the bad thing, depending, is that all of the options got some votes. That's good. And I see that the biggest ones, a lot of people, almost half, say they can continue with CropSAR for agriculture, which seems logical because that's what we announced as the topic of this webinar. So these people are here. but almost as many people would be interested to see the application in forestry, and that's an area that we are pretty confident that this could work well. And another big winner is water. Almost 40% also are interested in water applications. So that's another one we take with us as a potential very interesting application, which would be quite different, quite challenging, I suppose. But anyway, it's good to know that there's at least people interested. So with that, I think we can give the word to you, to the audience, and poll your questions.
Thank you, Stefan. This was truly interesting, and there's lots of questions coming in. And I'll start from the top. Is CropSAR free to use?
Jurgen, maybe that's an answer for you. That's one that you can.
Well, no, we offer it through Terrascope through a licensed approach. So you can find out on the website itself what the cost is, but we use a crediting system where you pay X amount of credits per hectare to run CropSAR. It's a quite there's quite some computational effort that we need to put into this, so it's impossible to make it available for free, of course.
I can add to that. On Terrascope, every user gets 1,000 credits for free every month.
Correct, yeah.
So you can test out CropSAR for your applications before you start paying. But of course, if you're going to monitor 10,000 fields across the globe, we will not be able to do that with the 1,000 credits that are available.
Okay, but from my own backyard, it would work, I suppose.
It would.
Yes.
If your backyard is big enough.
And if you would like to monitor 10,000 of hectares, please contact us, because we probably need to set up a separate scheme.
Okay.
Okay.
Okay, moving on. Do you compute CropSAR every day, which means some interpolation to fill gaps, or do you compute it when SAR is available?
Well, obviously, we cannot compute it when there's no SAR data available. That's the case. If you don't have SAR data, you cannot. So it's aligned with that.
Yes, and maybe I should add, with the absence of Sentinel-1B that failed close to 2.5 years ago, there are parts in the world that are not covered by Sentinel-1 anymore. So in those regions, we really don't have any CropSAR available. Moving on, is there an API, for instance in Python, with which to access the data instead of going through the website and its UI?
Yes, that's what we showed. We showed the OpenEO interface, which we believe gives a really with a really good interface without too many technical hassles. So it's really yeah, we can recommend that.
And I should add to that, when you use the web interface of OpenEO, it actually also creates the code for you to run in Python, for instance. So you could set it up for one parcel, get the code, and then adapt the code for other parcels. A question: did you test CropSAR in highly cloudy areas like Brazil during the rainy season? Maybe Jurgen can give an answer to that.
Well, there are some regions in the world where it doesn't work that well, and that's especially around the equator, where it's always clouded, and in regions where you have more than, let's say, 2-3 months in a row cloud covered, there the predictions also start to show some larger variations. So in fact, you need once in a while, so at least once every 2 months, an optical image. But for most of the regions, this will work.
All right. Do you calculate the grassland insurance index per region, province, ground type?
You might know that.
Well, we don't calculate that ourselves. We provide the CropSAR service to our customer, and they developed their own solution on top of that. So we are just one of the building blocks for this solution.
Okay, moving on. Do we have a research paper explaining the method behind CropSAR?
The answer is yes. We should have added it to the presentation, but we can. Yeah, I'm sure
maybe we can
provide.
add it to the recording later on that we will publish in the coming days.
Yeah, that's a good plan.
Yes, we can share it through the website.
Okay. And then finally, thanks for the interesting talk. Do you have some agricultural products out of CropSAR, like planting date, harvest date, crop type, tillage type, cover crop detection, and so forth?
Yeah, so for a number of cases, we use CropSAR as a basis to for crop classification, for example, and not only crop classification for main crops, but also for cover crops for emergence and harvest detection. So it is in fact a building block for many derived products, if you like. So we use it frequently and in a various set of added value products.
All right. Stefan, you showed the color and the near infrared red images, but the question is, can we provide a prediction for all of the Sentinel-2 bands?
Well, in principle, it should go the same way. I don't think we have really concentrated on looking at SWIR bands because there was not a direct relevance. But in principle, it should work as long as they are correlated with what you see in the SAR signal. It should work, yeah.
One of the attendees is currently exploring Fuse TS, and in one of the notebooks examples, it uses CropSAR. Does it mean that Fuse TS uses CropSAR products? I have no idea what Fuse TS is.
I don't know the Fuse TS either, but if it says it uses CropSAR, I'm happy to hear that.
Okay, and then final question for now. Which method is used to gap fill for the indices?
Well, that's actually the basic CropSAR 1D that we explained earlier, that when you have just an index, you can rely on this parcel based and fill in the gaps with the SAR data.
All right. A more basic question is asked: what is the difference between FAPAR and NDVI, and which one should I use for which purpose? This is a bit outside of the subject today, but FAPAR is a proxy for photosynthetic activity, and NDVI is an indicator of general plant health. So they're not exactly the same, but a healthy plant will probably have a lot of photosynthetic activity as well. So all of these indicators are related, but not exactly the same.
So it basically comes down about what you exactly want to know, and then you start differentiating between them.
And then a question: which cloud cover mask do you use?
I think what we do, we worked at the beginning with the standard cloud cover mask that came from with the Sentinel-1, Sentinel-2 product, but we moved to a more strict one, so we didn't have any parts of the image containing still some clouds. We are a bit more strict on that. So we had our own cloud masks to be sure that we only use unclouded imagery.
Yeah. So in general, if a cloud is detected somewhere, we take an additional number of pixels around that cloud that we're not using for CropSAR, because they may be affected either by some cloud still or cloud shadow. And that was a very active Q&A session. But still one question coming: any parallel plans to improve the spatial resolution?
Well, if you can work magic in the time domain, you could do magic in the spatial domain as well. A very good suggestion, but I would believe it requires quite a very different approach. But
yeah,
you never know.
And there are some basic research ongoing, but I think it's way too early to make any statements about this.
But you will hear about it once
Yeah.
we solved it.
Yeah.
Okay. It's almost 5 o'clock, so unless
We should wrap up, yeah.
somebody still posts questions while I'm talking, we will close. Maybe Stefan, you can move the slide.
Oh yeah.
So before we
This
close, let me briefly encourage you to reach out if you have any use case that you would like to share via Terrascope. Terrascope is a platform for all to use. So if you have a use case using Sentinel data, we will be very happy to offer the platform to you for promotion. We will be organizing new webinars in the fall. And we certainly are looking for new topics and use cases to highlight. So if you have anything that you think would be interesting for this public, please reach out to us. You can use the contact details in the next slide to reach out, and we will be looking forward to any suggestions that you have. And then finally, thank you all for joining us, and thank you, Stefan, for explaining. We hope to see you again in another webinar later this year. You will be able to download the presentation video in one of the coming days, and you'll get an email when that is done. So thank you, Stefan and Jurgen, for helping us out and presenting. Thank you, Evelyn, for making this a smooth organization. And all of you, if you're living in the Northern Hemisphere, I hope you will see some summer, because we haven't seen any yet.
Yeah.
Thank
the
you.
good thing is CropSAR has been extremely valuable this year.
That's true. Okay, thank you.
Bye. Thank you.
Okay. Thank you. Bye-bye.